Hello, everyone. We have already learned the relevant knowledge and principles of circuits before. Before designing the PCB, it's essential to verify the circuit's feasibility using simulation software. We need to design a simulation circuit diagram for a DC-regulated power supply module using the simulation software Multisim. If specific components are not available in the component library, use components with similar parameters as substitutes. Additionally, measure the circuit's operating parameters to verify whether the circuit's load regulation meets the requirements. There are two learning objectives for this lesson. 1. Get further familiar with the use of Multisim. 2. Learn how to use simulation to verify the performance of the designed circuit. This simulation experiment is designed based on the schematic diagram. We will verify a DC-regulated power supply circuit with an input AC voltage of 12 volts, an output DC voltage of 5 volts, and a maximum output current of 3 amperes. The simulation software used in this lesson is Multisim 14.0. Multisim is a software specifically designed for circuit simulation and design. It includes features for graphical input of schematic diagrams of circuits and input of descriptive language of circuit hardware, with extensive simulation and analysis capabilities, and is one of the most popular EDA software tools available today. Multisim's interface is shown in the diagram. Next, we will proceed with drawing the simulation circuit. Step 1. Create a simulation file and save it. Open Multisim 14.0. In the menu bar, left-click on File, select Design, and then click on New File to create a blank design. To better save the related operation data of the design, we should first create a folder and name it appropriately. Then, name the design file, Power Supply Circuit Simulation Experiment, and save it in the folder. Step 2. Design the circuit in the design file. The first process is to find the corresponding simulation components in the software based on the schematic diagram. Firstly, find a power supply component in the power supply library in the component toolbar. Double-click the power symbol to modify the power parameters. The voltage is 12 volts and the frequency is 50 Hz. Secondly, select diode 1N4007 in the diode library and copy and paste it. Select the corresponding capacitor in the basic component library and change its label name and value in the circuit workspace. Select the corresponding voltage regulator module LT1085CM in the power component library. Add 3 resistors and adjust their values accordingly. Select two multimeters in the instrument toolbar to measure voltage and current respectively. Use XMM1 to measure voltage and XMM2 to measure current. Then copy and paste diode D5 above the voltage regulator module. Now we have found all the simulation components based on the schematic diagram of the circuit. The second process is to connect the corresponding simulation components according to the schematic diagram of the circuit. Connect the positive electrode of the power supply V1 to diodes D1 and D3, and the negative electrode to diodes D2 and D4. Note that diodes have unidirectional conductivity, so D1 and D3, as well as D2 and D4, must be connected correctly. Connect the negative electrodes of diodes D1 and D2 to the input terminal IN of the voltage regulator module U1. And connect the positive electrode of capacitor C1 and the negative electrodes of capacitor C2 and diode D5 to the input terminal of U1. Connect the output terminal OUT of U1 to resistor R2. Connect the adjustable voltage pin ADJ of U1 to resistors R2 and R3. Connect the negative electrode of XMM2, which measures the current, to the positive electrode of diode D3, and the positive electrode of XMM2 to resistor R1. Connect the negative electrodes of capacitors C3 and C4, as well as resistor R3, to the negative electrode of XMM2. Connect the positive electrode of diode D5, the positive electrodes of capacitors C3 and C4, resistor R1, as well as the positive electrode of XMM1, which measures the voltage, to the output terminal OUT of U1. Connect the negative electrode of XMM1 to the negative electrode of XMM2. Finally, connect the negative electrode of capacitor C1 and the positive electrodes of capacitor C2 and diode D4 to the positive electrode of diode D3 and ground. Now we have finished the process of connecting the corresponding simulation components according to the schematic diagram of the circuit. Next, we will proceed with the simulation test. Open the page where the multimeter displays the data, and then click on the simulation button using the mouse to start the simulation. The simulation starts, and the measured voltage with XMM1 is approximately 5 volts, while the measured current with XMM2 is approximately 3 amperes. The simulation achieves the expected results and is successful. Finally, let's review the content of this lesson. Recognize and use software Multisim. Learn to use simulation to verify the parameters and functions of DC-regulated power supply circuits. That's the end of this lesson. Thank you for watching.